All of us are used to online shopping, where we constantly get upsell banners across our screen. But one can't touch the item or see it in person. What if there was a way to experience this upsell opportunity while you're at a physical store? In this demo, we will show an Art of the Possible app describing various technologies, including blockchain, to show how the IBM Z scale-up architecture provides the ability to handle Black Friday-like data volume scenarios. Through the use of microbeacons as an IoT device, shoppers can be located by their geospatial positioning within a store. As I enter a store, a beacon detects me and notifies me where my items are actually located, along with any specials that may be running that day. The retailer can actually track my journey and, along with other shoppers, better understand where the most traffic is generated via these beacons. As a consumer passes close to a certain location, a notification could appear on their phone based on combining and analyzing past purchase history, what similar customers like, and their social media posts. This personalized app enabled the store to influence a shopper to visit another location outside the scope of their shopping list, creating a possible upsell opportunity from the beacons that provide a wealth of analytics that is analyzed real time. In-store beacons tracked customers' movements and broadcasted the information to the phone. The phone receives this and sends the beacon location data and the owl information to the back-end systems. The back-end systems performs detailed analysis such as an in-store optimization algorithm which guides the user to navigate where items are located. Other analytics and deep learning capabilities in the back-end include promotion, recommendation, blockchain, previous purchase history, and social data analytics. Once the request is processed, a response is sent to the mobile app. Now imagine the big data scalability problem and analytical analysis required, with thousands of shoppers in thousands of stores, each receiving their own personalized shopping experience. Generating millions to billions of web events and right-time analytical analysis for all the shoppers using the app in a Black Friday-like scenario. IBM Z, with its platform attributes of high availability and security, is capable of handling 30 billion web events per day. Now let's start by opening up the Interconnect demo app. The app is opening, and I want to log in. I notice that this app will allow me to explore the pedigree of food. Maybe I will explore that later. Now I log in, and I enter my password. I love IBM Z. Here is a saved shopping list that I entered previously that morning. Wow, I noticed that the app actually inserted a recommendation to me. How did it do that? Based on this list, real-time analytics was ran, and based on my past historical purchases, it correlated that every time I buy chips, I tend to buy ranch dip. As a consumer, I probably saved myself a trip back. As a retailer, I was able to increase my sales revenue by making suggestions leveraging analytics ran on the shopper. I see that I got a mobile notification about a particular offering from the store I was supposed to visit that may interest me. The app knew my GPS location and the stores nearby that I intended to visit, and presented me with a 20% off coupon for that store, and it also alerted me that it's just a mile away. Spark Analytics, running time-sensitive calculations behind the scene, knew I intended to go to that store, and knowing my current location, it provided an alert with an incentive to stop by the store now. With this coupon, the retailer actually created an upsell opportunity and drew the shopper into the store leveraging time-sensitive analytics that IBM Z run. So I press Shop Now. And then by pressing Find, the app showed me turn-by-turn directions to drive to the store. And I can move around the map by just swiping the screen. Once I am inside the store, the microbeacons picked up my geospatial location and actually plotted a real-time in-store route optimized path for picking up items. By combining the ability to recommend items that were not on my list and real-time route optimization with a low latency response time not available on distributed platforms, We enhance the experience for the shopper and increase the likelihood for a positive sentiment, which could lead to the shopper being more open to buy something outside of groceries and not lose a potential sale if a shopper passed an item. The capability for a retailer to inject suggestions into a shopper grocery list app screen along with the path you are following is powerful. Now next we're going to show how blockchain proof of concept can be utilized for a pedigree of food use case, showcasing technology readiness for when or if the industry agrees on an implementation strategy. Blockchain is a public ledger of all transactions that have ever been executed that constantly grow as completed blocks are added. So I am a health-conscious person, so I'm going to select pedigree, and I want to understand more about my ingredients. For example, I want to monitor the amount of sugar, butter, calories, and see if the ingredients are organically certified, such as my eggs. So by selecting eggs, I see that the eggs are organically certified. I also want my cake to be gluten-free, so I select flour. I see that the flour followed a gluten-free supply chain. I am also socially and environmentally conscious, so before I buy this cake, I want to know what country it was made in. How environmentally friendly is the manufacturer? Do they use child labor? Knowing these answers may influence whether I buy the item or switch to another brand. Thus, IBM Open Blockchain Technology can trace all the pertinent information I needed before making a purchase. The blockchain analysis that was presented to me was satisfactory, so I added it into my cart. Looks like I am done shopping and ready to go home. But wait, I see another mobile notification suggesting another item that I may like to buy, along with special discount coupon for that item. Here, IBM Z, leveraging machine learning and analytics in real time, queried my past purchasing history by going back to the system of record credit card history and analyzed my social media data where my discussions mention a particular interest. It also queried personas similar to me, and understanding their preferences made an upsell suggestion. But unlike an online banner, I can actually follow directions from the app to an actual store aisle and touch the recommended item. The recommendation is suggesting my favorite bottle of wine that will go with my planned party. Now, I had no intentions of buying this, but the recommendation enticed me and got me to walk over to the other aisle where this item was, increasing the chance of prompting an impulse purchase. Based on what is trending via social media and the analysis of other purchases from like personas, I am also presented with other upsell products that I may or may not consider. I noticed some suggestions on the Super Bowl that just happened. I think I'm going to go purchase a team jersey. Thus, IBM Z can not only query the system of record databases for past credit card purchases, but also understands the unstructured data from the social media and provided other recommendations. It's about delivering the right recommendations and trends to the customers at the right time. So now it's time to check out. But my personalized shopping experience is not over. I'm going to get loyalty points from the retailer as part of my purchase, and I can also use what I have banked with him instead of paying cash. The use of blockchain represents an improvement in security, as fraudster of gift cards or loyalty points will not be able to steal it. I now shut off the app as I leave the store. So as a consumer, I was reminded that if I was close by to the store and I wanted to visit, and I was enticed to go there with a coupon. I had a personalized shopping experience, courtesy of IBM Z, where recommended food items were suggested to my list and the pedigree of what I was buying. Once in the store, it was easy for me to find out what I needed following the plotted app route. And I experienced a further recommendation of something not in my list that I felt good about adding. The retailer, without using any advertising, but just leveraging time-sensitive Spark Analytics running on IBM Z, provided multiple upsell opportunities, including leveraging the mobile app to bring them into their store instead of a competitor's. Imagine the multiplier effect of multiple users in multiple stores, each receiving a personalized shopping experience, and the big data with velocity, volume, and variety that is created. Fortunately, the retailer had an IBM Z server that was available with no downtime, notifications delivered real time, provided secure transactions and communications, scaled to the volumes of shoppers in the U.S., and could run time-sensitive analytics that provided many upsell recommendations to increase revenue. Now let's switch from customer to nationwide dashboard from a store manager's perspective. By selecting one of the stores, a retailer can zoom in and receive insight on performance and possible recommendations to increase sales for the day. I see an interior map of the store aisles, and I can click to show the products. And I can also click to show the heat map of the traffic within the store that is updated frequently. A visual heat map of the store is gathered from store monitoring data such as iBeacons and security cameras to identify areas where customers have been shopping more heavily. Combined with the multitude of data collected from the mobile app users, recommendations are driven from Spark to help increase sales by targeting new promotions in hot areas. Store managers could use updated heat maps over a time period to redistribute items by moving higher margin items to higher traffic areas. This information can also be analyzed by a cognitive system allowing for automated placement suggestions of items based on traffic and other conditions. Now, using a weather forecast, as I clicked on St. Louis here because that's where my store was at, for upcoming days in Spark Analytics, forecasting is provided based on the previous sale history across a multitude of stores. A rainy day could be a good opportunity to trigger additional marketing promotions to bring customers into the store. Bright sunny days may recommend additional items for promotion for grilling or outdoor activities. What is selling in the store and items that are trending in social media can be correlated by Spark Analytics to provide further guidance into how shelves can be stocked. Using geospatial analytics, weather forecasts, current sales data, and trending items from social media across all the stores nationwide, the IBM Z was able to handle the scale of all these requests, enabling insightful decisions by the retailer. 4 major microservices provide solutions to the in-store path optimization with recommendation. All these services provide features through a REST API using StrongLoop. System of Record service. This stores customer purchase history and store inventory into DB2. Social Data Service stores all a customer's social data, such as tweets, into IBM Cloudant. IoT Service tracks store iBeacon sensor movements, such as the location of the customers inside the stores, and manages review data using MongoDB. And Analytics Service. This runs algorithms such as in-store path optimization, recommendations, and location based on geospatial analytics. It achieves its goal by analyzing and accessing all data stored in DB2 for the system of record, MongoDB for the IoT events and reviews, and Cloudant with social media data. Now, the retail store creates a pedigree on the open blockchain with 3 chain code services running in Docker containers. DB2 on ZOS chain code service maintains the food inventory list and their sources of origins. IMS chain code service maintains all the food ingredients, and Kix chain code services maintains all the transaction processing for the entities on the blockchain. Once all the chain code services are deployed, an open ledger with IBM Blockchain is created among these 3 chain code services. The mobile app accesses this service, finds the pedigree of a particular item in the store, and its source of origin. In a similar fashion, a blockchain was also set up for loyalty points, allowing customers to pay using loyalty coins at checkout or earn loyalty coins. Now that we have explored the architecture, we can see that the server is capable of handling all the traffic that could be generated on Black Friday, assuming every consumer is using this retail mobile app. Imagine if your store had thousands of people inside the store and multiplied by thousands of store, with each customer using the personalized shopping app generating millions to billions of events, such as geospatial analytics, sentiment analytics, and in-store path optimization. Here we show the heat maps from the store radiating, creating tremendous traffic from multiple shoppers into the server for time-sensitive analytics. To be successful in a Black Friday scenario, your IT architecture needs to address 5 major areas: scale, availability, security, performance, and business agility. The multitude of web events doesn't impact the response time, as IBM Z had the capability to scale to 30 billion web events per day. Ever been shopping online only to have the website crash? This won't happen on IBM Z with 5 nines of availability. Watch out for blazing performance as each open source product runs 2x faster. Any mobile transactions or loyalty payments have to be secure, and all transactions are protected through SSL encryption with IBM Z Protect Key, which is 28x faster. And for business agility, rapidly develop your app with our various pass options, leveraging OpenShift, and various orchestration tools. Personalizing the shopping journey, leveraging the extreme scaling capability of IBM Z, allows stores to target shoppers, creating a positive consumer experience and increased retailer revenue, thanks to the Innovation Lab team and the iOS Garage.